Door corner construction. Welcome to Building Knowledge 101. In this session, we will cover door corner construction options and the forces applied when an entrance is opened.
Now, every time a door is opened or closed, there are two forces that are applied to it. I'm going to cover this with you real quick. Every time you open and close a door, you get two forces. The first force is when you pull the door open, you get what's called twist. So twist occurs as you pull the locking style and you pull from the cantilevered edge out here, and that causes a pulling motion to follow it here, and you get a twisting along the joint at this point. The second force is called racking. Since your hardware, your pull, is not centered in the door, it's typically going to be toward below the center line. As you pull a door, you start to pull the bottom out first, with the top then following it. That causes racking. So again, every time you open a door, two forces of twisting and racking are applied to your joints where your rails are attached to the vertical stiles. So the construction of that corner connection is very important because it has to hold up to twisting and racking. So let's take a look at some of the common methods of creating door corners. One common method is called tie rod. So with a tie rod, you're going to drill a hole through the vertical stiles and run a threaded rod through the bottom rail and the top rail into the vertical stiles, and then tighten down with a lock nut. This is called tie rod construction. It's a very simple, easy way to build a door. It allows the manufacturer to ship the door not down. Subcontractors can fabricate their own doors very easily using tie rod construction. It does periodically have to be tightened up because of the forces of racking and twisting. It's going to loosen a little bit, so that has to be tightened periodically. Another similar means of construction is called screw spline. So with screw spline, your top and bottom rail have extruded screw raceways in it. So fasteners are run through the vertical stiles into the horizontal members and tightened down. Once again, because of twisting and racking, periodically those do need to be tightened down to keep the door functioning correctly. Mechanical clip and fastener is the third method. You can see here there are clips attached to the sides of the vertical stile, and then the bottom rail, top rail is slid over those clips, and then it's fastened down through the rail into the clip. So this is mechanical clip and fastener construction. Final method I want to look at is what we call dual moment construction. And dual moment references those two forces of twisting and racking that affect the corner connection of every door. So the dual moment construction is designed specifically to counteract each of those forces applied to the door. So to begin with, we're going to attach mechanical clips to the vertical stiles. Once those are in place, then a hole is drilled through the horizontal members and a deep sigma plug weld filling the hole, that bonding the horizontal rail to the clip on the vertical stile. So it actually bonds the two together with that deep sigma weld that goes through the top and bottom rails. And then finally cap it off with a fillet weld where your joints are. So kind of to summarize what that looks like, let's take a look at it here. Here's your vertical stile. You've got your backers for the clip, the mechanical clip into the stile. Now we're going to bring the rails on, weld the joint there, and the sigma weld, and that completes the corner construction. This is the backer rod for the butt hinges, and now the door is completely put together. So again, think about racking and twisting because those are the forces applied every time a door is opened and closed.
That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.